many of you think it's way too hot? Okay. Welcome to the Kiwi Talk. My name is Jan Monstedel. I work in imaging topics since about half a year or 3/4 of a year. And I'm going to show you what Kiwi can do for you. First of all, I'd like to ask, how many of you actually know what Kiwi is? Oh, quite a lot. And how many of you use it to make images? 2, 3, 4. It's also quite a lot. If you want to tell something about the images you are creating, I'd like to know that.
Well, live image.
Live image, ISO or USB?
Excuse me?
ISO images or USB images?
ISO for now.
ISO.
But USB in the future.
Okay. And how about you?
USB, because you can have your hard drive basically with you and just carry around like music and your documents. Basically your operating system with you if you have a USB. Great.
We have one or two power users here in the room. I won't probably tell you many news because you already had all the pain that you can have probably with the configuration. I'm going to talk about this. My demonstration presentation is split it in basically 3 parts. First of all, I'm going to talk about the history of Kiwi, how it was developed, why it was developed, by whom it was developed. Then I'm going to give a very brief example what Kiwi can do for you. If you don't already know this, you too may fall asleep during that minutes. And in the last part, I'm going to talk about what I do for Kiwi, because we wanted to give new functionality to Kiwi that it does not have at the moment. And I'm heavily working on that. So I'm going to talk about, I think, 5 minutes or at least 5 minutes about what I'm doing. And if you wish, I can show you a current configuration file, but we'll come to that later. So, first of all, introduction. What is Kiwi? Kiwi is a command line-based toolkit, which means it has no nice GUI, nothing to click around. But for that reason, you can integrate it in a toolchain process. So when you have a build system, for instance, and want to create ISOs automatically, you can integrate Kiwi calls in your scripts, in whatever scripts, Bash, Perl, whatever. And it is usable as a base tool for high-level applications. So if you wish to make whatever Qt or web frontend to generate your configs, you can do so and run Kiwi as a backend, which is a really nice thing. But Kiwi is not a product, so there's no point in. We don't sell it as is and as a complete tool. You can integrate it, and it's still under development, and you will probably find bugs. So I can repeat what Seifi said. Bug reports, please file bugs. It's in the Novell wiki, Novell Bugzilla. It's OpenSUSE.org system imaging. I have this not in my slides, so but you'll find it probably if you search for Kiwi in Bugzilla. The original program was developed by Markus Schäfer. The original plan was that he gives his talk about his part of Kiwi himself, but he cannot attend for private reasons. So I'm taking this. And his original idea was he wanted to create a USB stick, just like Francis. He wanted to have his system to go and boot whatever machines he could for his and carry his data with him and just have his special system on every hardware that he has. Then later, James Wilcox, aka Snore, in the OpenSUSE Kiwi channel, has the Thin Client project, which is targeted to provide an image as small as possible. And Gigi Stohil, aka CyberOrg, is in active development for the LSTP project, which is German.
LTSP.
LTSP. Oh, I misspelled that. Oh, I'm sorry. Yep. Okay. And I joined active development in April and wrote my modules. You won't find my code in the repository at the moment. Just one small module that I use for some utility functions, which are subject to change, of course. And as soon as my code works, I will commit it. It's nothing secret. It's just not yet operational, but it will take 2, 3, 4 weeks maybe. Of course, I will get back to this in the third section. So the current project status is an overview who uses Kiwi at the moment. The SUSE Linux Enterprise Point of Sales project uses Kiwi to create images. Also the Thin Client project is an official product made with Kiwi. And some hardware vendors use Kiwi to make preload images that they can dump on their disk and give to their customer as a pre-installed machine. We actually have one preload by Lenovo. We made this with Kiwi. It's released. And I mean, they made it with Kiwi. We taught them how to use Kiwi to find all these problems that you have when you use it for the first time. We figured everything out, and now they are using Kiwi to make their product. And there are some community projects. Actually, if you ever tried a KDE Live CD, this is made by Stefan Binner, aka Binary. He also uses Kiwi. And whenever he has some questions, he drops over to me because he lives in the room next to mine. And of course, any user who wants to create his custom system can use Kiwi to do so. And yes, exactly, that's what I mean. You tell me if anybody has, I asked that in the front, and I know that Seife, for instance, used Kiwi to make a rescue system, which is very interesting.
Me again. It's an old X32 ThinkPad which has no drive, and I really regularly update to the latest OSUSE factory code. And in the evening, before going home, I have to call my colleagues, one moment I need to reboot first. Because what if the update kills the kernel or the bootloader? I'm sitting at home, for some reason I need to reboot, the machine won't boot, I won't have a drive, I can't recover it. So I did with Kiwi a live booting USB stick, which I just use as a recovery, instead of a recovery CD. I did a recovery boot stick. And right now it's when you try to show it, the X server doesn't start up for some reason. Probably I booted on a different hardware last time, so I need to. But,
yeah, but we have one that boots. I'll show that later.
But it's a much better rescue system because it's so cool. It has MPlayer, it has all browsers, it has everything you need. Yes, of course. It's much better if you can listen to the MP3. You can listen to the MP3 music from the one partition while your file system check is checking the other partition. So that's really cool stuff, and I really appreciate it. So you can use it for more than it looks. So it's really cool stuff.
Seife is one of the guys who really gives good input. He comes sometimes, drops over to my office and say, yeah, couldn't we do this like that, blah, blah, blah. And he has really good ideas on that topic because of that rescue system. And of course, but I don't remember that you ever reported an enhancement bug on Kiwi.
Yes. Yes, I did in your office.
In my office, yeah. I see you had a question?
When you were talking about the history, does the name actually have a meaning? Or
you mean the
where
name
does Kiwi come from?
That's one of the secrets. You have to ask Marcus himself. He just, I think, he told me once, while we drank a cup of coffee, he told me it's just because it sounds nice. He didn't think of the birds, because when you look at the Kiwi and the official Kiwi website, I can show it right now. I plan to show it anyway. If network is, yeah, my network is still up. We have the official Kiwi website at values.de, which actually has a picture of a fruit, as you see. And he calls the Kiwi community, the developers, Cyberorg himself, and me, the fruit lovers. So this is the official web page. Okay. Now we're going to how does Kiwi work. If you want to use it for the first time, you have to do several things. Because there's no really brief overview, I collected some useful links. We had often trouble that people installed Kiwi and started to edit the wrong config XML files. Namely the ones in user share packages, Kiwi, user share Kiwi images. And these config files must not be edited. That's why Marcus provides some examples. since Kiwi version 1.99, he has 2 examples that you can use as is. And we have the official OpenSUSE Live DVD things checked in Forge SVN. And that's why I collected these links. The website was just a quick hack written on Thursday to collect all the links for the download repository. So you can get examples. These 2 examples are in the normal documentation. You get this if you install the Kiwi package. And the OpenSUSE images are in Forge SVN 1. There you can. That's nice that we have network here actually. And you can take this KW Live CD configuration file. This is a good point to start if you should open this with. Oh, it works. That's how a configuration file looks like. This is quite long. I'll explain a shorter example later. So, what else is on the website? We have links to documentation. First of all, the documentation that comes with the Kiwi package, which you'll find in user share doc packages Kiwi as kiwi.pdf, which is really, really, really well written. This is one example for really good documentation, I can tell you, because Markus wrote a lot of documentation and he was convinced by Thomas Schreible to use this, to create it with DocBook. And it's really well written. You can write your own documentation if you have something and put it in this. And we wrote some real life scenario tutorials. When I made the preload image, I wrote something about the preload and about the USB. This is actually my contribution to this docu. And a few weeks ago, Thomas and Markus started to write a quick start tutorial, which you will find in the build service documentation actually. This is in this link. You will find the books in, and there's a quick start Kiwi. The problem is that the PDF is not in the repository, so if you want to build it, you have to check out that repository, you have to install the SUSE.doc package, which should work by now. We found out that it doesn't, you can't install the package from the online repositories due to missing. If you have the DVD, you can install it, but I think the package got fixed on Thursday and will be available through the updates. And you can take a look at the quick start because of course I have a compiled version with me, and which is really an autodidactic way, because it doesn't start with technical details. It starts with how can you create, what is Kiwi, and what do you need. It tells what packages you have to install when you want to make ISO images. When you want to make USB images, there are different sub-packages. And it has some sample calls that you can execute. You can use, for instance, he shows these 2 examples, which you already have installed, and you can just go there and use these configs and run commands, which you find in this documentation, namely these. And this should work if you have a valid installation source. So it's pretty straightforward. Just take a look at this quick start guide and get started. So basically you have to install a Kiwi package, Kiwi tools package, and Kiwi desk ISO boot, Kiwi desk USB boot to make ISOs or USB images. There are some others for thin client, there are some for the WISE terminals. You probably don't have to use them ever, but if you have a WISE terminal and want to make an image for that, you have to use this. It's also available. Your main job is to create the config XML file, with the one I showed you before. You can start from scratch and create your own, or you can just take one and modify it. That's the usual way. You check out one, you take the KW Live DVD, or you take the some other that you like or is almost what you need and just tweak it a little bit and you get your own image. The build system looks like this in an overview. You need source repositories for the RPMs as input, and you need the config XML file basically. You also need some other files which are shown in another slide. You need a build host with at least about 5 gigabytes is sort of minimum. Better is 10, better is more, of course. That you don't have to delete the old image to create a new one and have enough space on your disk. And what comes out of it is an image. This is not necessarily a CD. Actually, it's just a nice symbol. The image can be a virtual machine image, or a USB image, or an ISO image, and among some others. So it's just because it looks nice. Okay, that's a slide explaining sufficient resource, especially hard disk. Of course, it helps if you have a lot of memory. I built an image on a machine with 512 megs. It took, I don't know, 40 minutes or so, and the same image on a 1 gig machine took 20 minutes or less. So memory matters, and hard disk drive. It's the main. You don't need a quick CPU. The configuration directory contains several files. The most important one, config XML, containing every information that your image needs. Package list, repositories, usernames, user IDs. We can switch back to this. I can explain it on an example. Where was it? Here, I think. Starting with image tag containing description, who made it, is the contact, the name of the image, then the preferences specifying which boot images should be available. In this case, ISO is the default, but you can also use as an option OEM image, which is used for the preloads, and VMX for virtual machine, XEN for XEN kernels, or USB for the USB stick. One warning at that point: if you make USB sticks and you install Kiwi, you may have a machine without SquashFS and without AUFS. You have to install these manually. They are not required by the package. Markus says he says who wants to make USB and uses SquashFS probably knows what he does, and the package should not require these. Then you specify version, size, what package manager you want to use. Actually, they support Smart and Super. Both have some issues. There are some things better in Smart, some things better in Super. Sometimes it doesn't work with the one, but with the other. And when you use Super, the version is important. You must have a recent version of Super. And yeah, that's package management is a topic for itself. In this particular case, we have two profiles for KDE and GNOME, because Kulo used this configuration to make the KDE, the OpenSUSE Live DVD, which is one for KDE and one for GNOME. But the main thing which you have to do is the packages section here. You have to specify which packages shall be installed in the image. You can use a package list if you have one. You can specify a package name for each package, which makes the list very long. Or you can use OpenSUSE patterns, which are resolved, but sometimes you run in trouble with that. And you can specify packages that you don't want to install by saying ignore name. When you have a package that you know it's not in the repository but is required by some pattern, then you say ignore and it is ignored. I don't think that we have an ignore here, but I can look in the... Yeah, as we see, Kulo used the package list and didn't rely on the patterns because they cause trouble sometimes. Especially if your installation repository and the patterns are not in sync, which happens sometimes when you build with the leading edge repository. So that's pretty hot in here. Okay. Now, I'll briefly give a real-life example. Imagine the following situation. You wrote a program for your diploma thesis or whatever, and have to demonstrate it on, say we have a distributed system, you want to demonstrate something which has client-server application, and you need two machines for this. Your prof says that you have two machines in the lab, but you cannot make sure that they are installed correctly, and you can't be there the day before filling with the machine. Then in the evening some other guy comes, uninstalls the package that you need, and you run into trouble when you give your demonstration, nothing works and you fail. which is very black and white, of course, but it doesn't look good if you have a half an hour demonstration and need 20 minutes to set up your system. So what you can do is you can create images for both machines and put your own package, your own software that you wrote into your image. You don't need to do anything more than just booting it. This can be done in two ways. The most convenient one is if you have an RPM package, then you just link your, and the best way is, of course, to have this in the build service account. I have to say that because I'm on the build service team. Then you just register this particular build service repository as an additional installation source, require your package and build your image. Everything's fine. If you have no RPM, get a build service account and make one. If that's too much work, of course you can tweak your package in manually by just adding every bit of software that you manually copying files to user bin or user share something, which is more work maybe. If it's a simple program, it's less work, of course. And it's also possible. And it's not so complicated because you can use overlay files which are copied as you provide them on your image. I'll show that in the config tree later. So the scenarios that you have a mounted DVD or a mounted online repository, you have your build service home project containing your package. You have a build machine using Kiwi and you create your own image on USB stick that you can boot and make your demonstration from hardware, and you don't have to care about what the machines are. You don't have to prepare anything the night before. You just plug in your USB sticks, boot from them. Of course, you have to make sure that the machines actually can boot from USB. Some old machines don't. And then everything's fine. You get an A+++, if that's possible. And now I'm going to, first of all, I'm going to show the structure in the demo. As you can see here, this is a directory. This is the demo. I wanted to show this one. Excuse me. This is a very basic example done by Marcus. This comes with Kiwi. You have basically the config XML containing all the information that we talked about. You have the config sh, which is a script that runs after the base system is installed. And you have the root folder. Now this is interesting because are we already running out of time? Thank you very much. You have a root folder containing etc folder, and in this etc folder you have some things, sysconfig, and these files are putting the image as is, so you can override the default images by them. If you want some file lying in user bin something, you just put it under that root folder, root user bin something, and it appears in your image as is. So this is the second way how you can get your own programs into the image.
How do you take care of ownerships and permissions of the files? Do we have to set them correctly?
Yes. Yes. That's one point for which was discussed recently. Kiwi runs as root. You have to run Kiwi as root, and I think all of these files actually belong to root. Can you look at that? We have the root folder. And yeah, everything belongs to root. So you can change the ownership of these files, and I think the image contains them with the right ownerships. But I'm not absolutely sure about that, so you may want to ask this on the mailing list or on the channel. If you have to know this for some purpose.
I'm just curious.
Yeah, okay. Yeah, but if you have to know that, drop a mail on the mailing list or just asking the OpenSUSE Kiwi channel. Some guys will be around and help you, for sure.
No problems if you use SE Linux.
If I use?
SE Linux.
Which is?
Security and security.
I don't know about that. Sorry. But you may drop a mail on the Kiwi Devil mailing list for that and ask Marcus. He can probably answer everything. because he knows the code, he has it in his brain, I don't know. So what else can Kiwi do for us? Now it's getting auto-build interesting. It's about how we create our products. We have a system internal called auto-build, which is our package and media factory. We have build clients, and we have a scheduler running, collecting build RPMs in raw trees. We have trees for each architecture containing all the RPMs. And to make a product out of this, you have to gather one installation repository, which is when you use Kiwi at the moment, you have to provide one. Either you have the DVD or you have the online repositories, but you have to use a fixed repository with metadata that you can install from. And this is a weak point because Kiwi actually cannot create repositories. This is what I'm working on. I want to teach Kiwi how to make our repositories, to put some automatism and auto-build functionality into Kiwi, that you will finally be able to create your own installation repository from raw RPM directories, from other repositories, from directories containing plain RPMs with no metadata and no version information and nothing, and finally create one repository and applying some overlay mechanisms to say you have 10 repositories prioritized from 1 to 10, and you want to take packages from the one with the highest priority first. But you may want to override for some special cases. You have a package in priority 1 and priority 5, and you want to use it from the priority 5 repository, no matter that it's available in the other one. And we have to put all these information in the config XML file. And I write a module that handles these problems. And that's why it says not yet, because it's work in progress. I think I already told that. Yes. Should have shown this before. Product creation at the moment is what I told with what the auto-build team does. Creating installation repositories, creating images from that. There are steps. You have to create metadata, you have to collect packages, you have to resolve dependencies in parts to make sure that everything is installable. And finally you have an installation repository from which you create FTP repositories, DVDs, BitTorrent files, whatever, that we distribute as such. And the new approach will be that we have a Kiwi module. We have to expand the syntax of the config XML. We have to put more information into it. This is already done. I'm working on a module that evaluates this data and creates the repository, which is still work in progress. And we have priority for repositories when you have 10 repositories and you have files in more than, you can have files which are in every repository, and you want to take it from a special one. Then another important thing is that we need script hooks. Some packages have to be dealt differently. Installation images, for instance, is one of them, which has to be unpacked, and then a script has to be run after it and has to do certain things, moving files or copying files. So we have to provide script hooks that you can write a script, provide it in some URL, and which is run after the package is downloaded and copied to the right place. And as I said, you have to allow exceptions when you make something for. Good example is if you have two architectures for 64-bit and 32-bit, and you have some 32-bit packages that you need on the 64-bit image. For instance, if you want to use Firefox with a Flash plugin, that's one of the problems where you have to. I think you have to install the 32-bit Firefox and the 32-bit Flash plugin, because the 64-bit Flash plugin doesn't work for some reason, and you have to be able to provide these exceptions. That's just one exception. There are some others. And we still need auto-build knowledge, but we have to find another way to put it into the imaging. There's some automation done, and I can show you a current what we extended the config. because I have one with me, which is it this one? Yes, this one. This is one of the files that I use. That's why that I use for testing for my. The main thing is the new tag inst source. Within the inst source, we specify. It looks ugly at the moment because it contains a lot of comments. The main thing is the inst repo, where you specify a repository and a priority for the repository, and for FTP you need a username and a password, and in this case some location in our local system, and some other, which is a KDE build service repository, and here we have a local repository on the hard disk of the machine that I'm testing with. And I provided a package list, which is down here. It's very simple at the moment because I wanted to resolve some issues with the resolving didn't work in some cases. I just include 2 packages and test if these packages are available in all repositories. I have to make sure it's picked from the right ones for the right architectures. It must be available for all architectures that you have required. So this is a really bleeding edge work in progress testing environment. And another interesting part is the metadata tag, which is which specifies meta packages and meta files. And for meta files, we have the script hook here. We say a target is the directory where the meta file is copied to and extracted, and the script which is run after it. In this case, we have a. This is a bug actually, because I changed that to full path to non-relative URLs, because we said we provide a full URL for the scripts. But probably copied it a week ago or so. When this module is finally finished, you'll be able to make your own repository. Not only your own image, but also your own repository. The problem is that there are rare use cases for the community because you probably don't have your own auto-build running. And maybe interesting if you want to make a repository for when you have, say, 10 or 15 RPMs that you want to distribute with your own CD. You will provide a consistent tree with metadata, everything correct, and this package is included. Of course, you can do the same task with an online repository that you build your image from. So it's mostly internal. Nevertheless, I'm going to commit this to the kiwi repository when it's finished and when it works. You all may look at the code and report bugs and tell me if it's rubbish. Yeah, I know that. I know that your opinion is I know you would say that.
Doesn't work.
Yeah, doesn't work. Yes, that's RFC 1925 again. It has to work. So, and now, finally, if you have time, you don't want to go to the lunch break yet, you may ask any questions. I try to answer them or redirect you to the person who can.
Any plans on Yast integration?
Yes, and there is actually a Yast module called Yast2. I almost forgot that, thanks for the question. The Yast add-on creator. The Yast product creator, sorry. The Yast product creator is a front-end module written by Yoshi Superman, which is basically a front-end to create a kiwi config XML file. So you can actually test this and put some. You can put your own packages in there and create your own image, and it basically creates metadata for an installable repository based on an existing repository with existing metadata. It does not work with plain RPM trees, but it's already available. This is actually uses Kiwi as a backend. I should have mentioned that in the first section.
And the follow-up question, is there some relation with AutoYast, since it uses a pretty similar XML file to create the configuration of the installation target?
As far as I know, the AutoYast is completely different.
Okay.
It's something that uses completely different format. the AutoJust file is just creates a .rgz file from an image, and it does use some sort of XML file, but it has nothing to do with kiwi. That's for sure. So there's no connection between the AutoJust and the product creator.
Well, it would have been nice since there are some similarities, for example, in package selection. If you create package selection for an image file or a target system that you want to automatically install, it would be nice if there's some
Basically, I think they should just both use the usual package selecting GUI you have in Just and just use this as a module or something like that. So if you have
create an image or create an AutoJust.
yeah, and then you have a module. Basically, probably the installer would have to be extended to be able not to install, but to just write a package list. Might be pretty trivial.
I think the product creator actually uses the same module.
I also think I've used AutoJust once, the Just module, the Just module for AutoJust.
Yeah.
I used it once and it looked very much like a package.
We already discussed this internally, by the way. If we can merge something from AutoJust and product creator.
I think it makes sense.
But I don't know what's the plan to how fast this should be integrated or whatever. Yeah. Yeah.
You said product creator creates XML file.
Yeah.
Do you still then have to run kiwi from the command line to then create your image and then dump your image onto the USB stick, for instance?
You have buttons in the product creator which runs kiwi without. You don't notice this. You don't have to run it manually. That's what you mean. You have a big create button and it does the right thing. It's the do the right thing button. Anything else? No tricky questions? From you, Simon? Okay, show it. Then, first of all, I'll show my very last slide. This is a collection of ways to reach the Kiwi developers. The first one is the Reno channel OpenSUSE Kiwi, which is usually has at least Marcus in it, Francis I saw sometimes, myself and Snort and CyberOrg and some others, interested parties. Then we have you can ask on the build service mailing list, which is not, at the moment, not the right place for Kiwi questions, but may become, you can reach me through that mailing list, for instance. And Marcus runs two lists, Kiwi users and Kiwi Devil on the list berlioz.de. And of course you can drop me an email on Marcus. And any question that I can't answer, I redirect to him. So now we can show a system actually booting from USB.
Okay. I didn't try it, so.
You didn't try it?
I didn't download it on.
You said it works. If it doesn't work, I'll hit you. This side. Where's the connect? This side. Yeah. And if you want to show your recipe system, you're welcome. Just this is the
Call it recipe system.
this is the boot sector. When you start booting it, it should, yeah. The init in that case is a plain shell script.
But do you also use grub on the USB stick as the bootloader?
Yes.
Actually, on this laptop, it's quite close to the some laptops are almost that.
It's slow stick on this slow machine, right?
It's quite fast.
Okay. Unfortunately, I can't boot this machine from USB because the BIOS doesn't support it, or it's disabled for some hidden submenu of submenus. Does it do anything?
Yes. Press escape.
Yeah.
It's interesting. Press escape.
Yes. These outputs come from the Kiwi init RD shell script. You see, checking file system, writing file system with the partition. If you boot the USB stick the first time, I think the file system is created on the home partition, which takes a while. Yeah. image is a raw image with Firefox and
No, it's default desktop with all updates.
before desktop updates.
So it's a sample config script inside.
Yeah.
Okay.
But I guess only for the first time.
Yeah, but unless you provide a reconfig system equals 1 as a kernel option, then it runs its reconfigured by equals yes. Wasn't it reconfig system?
Actually, I had that problem that it's it only configured the X system at the first boot, and I wanted my rescue system to use more than one machine. So I said I need this option, reconfigure equals yes, or we're not sure how the option actually is named now. But we needed an option that just forces it to reconfigure X for an different hardware. It's just a much better rescue system. You can surf the internet. If you put the right packages on it, you can listen to MP3 music while it's happily checking your file system. So it's much better than the old-fashioned. I like it very much. That's why I use it.
Is it the wireless?
Yes.
That seems quite fast.
There's one condition, it's washer fast, and then there's a